So when you first open up SPSS, you'll find yourself either in the variable view, which we're looking at, or in the data view. The data view shows the actual raw data. The variable view shows you a list of the variables. The most important things to look at here are the label and the values. The label shows you the question that generated the data, whereas the values show you what the numbers mean. So to find out what the numbers mean, you have to go to the values field and click on the three dots to the right of that. And here it says 1 means strongly agree and 7 means strongly disagree. So obviously this is very important for you to know, so you can interpret the data. So let's go now to another question, another variable. This is a variable that is a constant sum scale, where 0 means 0 points allocated and 100 means 100 points allocated. Similarly, you can keep going and check what each of the variables mean. So for example, how would you rate the overall quality? The values are 1 extremely poor to 10 extremely good. And the next variable we look at is whether you'd recommend national, and 1 here is a yes and a 2 is a no. And in each case you find that out by clicking on the three dots to the right of the values field. This is education, and so on. So let's run some analysis by looking at a crosstab between whether someone would recommend national and cross-tabulating that with gender. So let's go to analyze and then to descriptive statistics, and within that look for crosstabs. Click on that and the dialog box will open up with all the variables on the left. Highlight the variables you want to put in the crosstab and click the right arrows. So we'll do that with would you recommend national. We'll put it in the rows. And the other one is gender. We're going to put that in the columns. Click on statistics. Make sure that the chi-square box is checked. Click continue. Then click on cells. And that'll allow you to specify what you see in the crosstab. You want to make sure you have row and column percentages checked, because that helps you interpret the information. So click on row and column percentages and click continue. Then when the output window opens up, you'll see the crosstab over here. You have the recommend variable in the rows and gender in columns. The first number in the cell shows you the actual count of people in that cell. So 124 males said yes, and they represent 53.7 of the row total. So the second number is the row total. 124 is 53.7% of the row total of 231. Similarly, females, 107 of them represent 46.3% of the row total. 231 people who said yes. The next set of numbers below that is the percent within gender, so it's the column percent, and you can see that 124 is 89.9% of the column total. There are 138 males, and 89.9% of them said yes. And similarly for females, 107 out of 123 females said yes, and that's 87%. Before you can interpret the data in the crosstab, you need to make sure that it is significant. The relationship between the variables is significant. And for that, you need to look at this table called chi-square tests. Look at the first row, the cell that says asymptotic significance, two-sided. That's the p-value for the chi-square test. Remember, the p-value has to be less than alpha in order for the result to be significant. By significant result, we mean for the variables to be shown to be not independent. So you reject the hypothesis that they are independent. So anytime a p-value is greater than alpha, you basically you cannot reject the null hypothesis, and therefore there is no association between the variables, and therefore basically the crosstab has no value. you can ignore it, because if there's no association, then the crosstab won't show you anything. So in other words, if the p-value is less than alpha, then you can interpret the data in the crosstab, but if it is not less than alpha, then you can basically ignore the crosstab and move on to the next analysis. In this case, the p-value is 0.469, which is obviously not less than alpha, no matter what alpha you use. And remember, the alpha you use can be at three levels: 0.01, 0.05, and 0.10. So in this case, the p-value is 0.469, obviously greater than the highest level of alpha you could use, which is 0.10. So obviously that's not going to be significant. Next, let's see how you can do some recoding of an existing variable. Basically, you'll need to recode your variable if it's a nominal or ordinal variable, and if it has a lot of categories and you want to put it in a crosstab, you need to make sure that the number of values is not more than 2. In this case, we're looking at a variable called income. It has 6 values going from under 10,000 to 65,000 and over. Let's recode that in order to put it into a crosstab. Now, in order to figure out how to recode it, first you need to decide how to collapse those groups into 2 buckets. So there are 6 groups. You need to put them in 2 buckets, and in order to do that, you need to see what the frequency distribution is of the sample in those 6 values. So now we're going to run a frequency distribution for this variable. Go to descriptive statistics, frequencies, and find your variable, and that's income. Highlight it and click on the right arrow and move it to the right hand side. And then you don't really need statistics, but just to show you, you can look for the following things, which in this case are not necessary. And click continue, OK, and you'll end up with a frequency distribution for the variable. In this frequency distribution, there are 6 rows, 6 values, and the second column shows you the frequency of in each group, then the percent, then the valid percent, which excludes missing values, and there are 18 missing values. And finally, you have the cumulative percent of the sample in each of those categories. As you can see, the best way to combine those groups into 2 buckets is by combining the first 3 groups. That way you have 34% in the one group and 66% in the other group. So that's the best possible way to balance out the 2 categories. And the reason you want to do that is because that is your best chance of finding a significant difference between them. If the sample size in either group is too small, then it'll just be impossible to find a relationship between any kind of relationship between that variable and other variables. So now you're ready to recode the variable and combine those 6 categories into 2 groups. Go to transform, go into recode into different variables. Don't go into the same variable recoding, because that'll override the original data. So make sure you recode into different variables, and so when you click that, you get the dialog box. Find the variable you want to recode, in this case your annual income. So you'll see the name of the original variable on the left, then a right arrow and a question mark. It's basically waiting for you to name the output variable. So now you've got to decide what the name of the output variable is going to be, and I'm going to call it recode inc. If you want, you can put in a label under 30K. Click change. Now you have to specify the old and new values, and you can do this one at a time. So when you click on specify old and new values, this box will open up. The old values are entered on the left and the new values on the right. If you do this one at a time, you can be sure you won't make a mistake, but there are shortcuts you can use once you're more familiar with how this works. For now, I'm just going to enter the values one at a time. So the way I'm going to do this is I'll take values 1 through 3 and put them all in the same bucket. and that bucket will be called bucket 1. So I start with old value 1, new value 1, and click add. Then I put in old value 2, new value 1, click add, and finally old value 3, new value 1, and click add. And you'll see the old and new values show up in the box on the right. And now I want to take values 4 through 6 and put them in bucket number 2. So old value 4 becomes new value 2, old value 5 becomes new value 2 as well, and finally old value 6 becomes new value 2. So now when you click add, you should check this list to make sure you've recoded everything the way you wanted it, and once you're satisfied, you can click continue. And then click OK. And you can check that the variable has been recoded because the new variable will show up in your data set. So if you go to the variable view and scroll down to the bottom, you'll see the variable has been added, recode Inc., and the label is under 30K, and that should take care of it. Now you can run a crosstabs as you have done before. Instead of gender, I'm going to use income, the new recoded variable for income, as my column variable. And let's see if that makes a difference to the crosstab. So I first have to get this old variable gender out. I highlight it, click on the left arrow to move it out of this back to the left. Then highlight the new one, click the right arrow, get it on the right side. Make sure statistics chi-square is checked. Make sure in cells the row and column percentages are checked. I click continue and then OK, and here's the output. So let's get this crosstab easier to see. So we have under 30K 1 and 2 categories in the columns, and recommend is still in the rows. So 81 people under 30K recommended, or he said yes, they would recommend it. So that's 87.4%, which is obviously a little different, but not a lot. In any case, we can check the chi-square test statistics to see what that means. And if you go down, we can see that the asymptotic significance is now 0.164. It's a lot smaller than we saw with the other crosstab, but it's still not significant. So it's still greater than 0.10, which is the highest alpha you want to use. So in other words, there's no relationship between income and willingness to recommend the company. And that's pretty much all there is to recoding. So here I want you to see the footnote at the bottom of the chi-square test table. Footnote A says 0 cells have expected count less than 5. And that's just to help you decide if the test is valid or not. If the expected count was less than 5 in at least one cell, then that would indicate that the chi-square test is not strictly valid, and you shouldn't really be using it in this crosstab. In any case, in this crosstab, it's fine. You don't have that issue.